My name is Ulf Ziemann. I'm the clinical director of the Department of Neurology at the University Hospital of Tübingen. I'm also a co-director of the Hertie Institute for Clinical Brain Research, and my particular research expertise is in the field of non-invasive therapeutic brain stimulation. I'm one of the PIs of an ERC-funded Synergy grant that is dealing with the question how to improve therapeutic brain stimulation in brain network disorders. Now, one can, of course, ask the question in which fields I could imagine, or you could imagine, the use of closed-loop implantable systems. So that would be invasive stimulation of the brain and brain-computer interfaces. And I can tell you from my vision that there are many applications that can be useful for this innovative brain stimulation technique. So you have to consider that brain disorders are like a symphony orchestra where the musicians might not play the right tones at the right time anymore. And then, of course, the symphony or the symphonic work is becoming destroyed. And the same is happening in the brain. So neurons would no longer be active at the right site and the right time. And then, of course, the effect is detrimental. So higher brain functions like cognition, language, sensory motor functions will no longer work properly anymore. And for that reason, it is a very important target to normalize brain function. And now, if you would be capable of reading brain signals and then use that information to stimulate these dysfunctional brain networks at the right site at the right time, that would be, in my view, an ideal approach how to treat brain network disorders in the future. So the brain interchange system is an excellent example and model for that philosophy and this target, because it records with epidural or subdural grid electrodes the signals from the brain, and these electrodes are bi-directional in a sense that they're also capable of stimulating. So this is exactly what we need. And I believe that this technology has many advantages compared to other approaches that are being researched about right now. So one is the Neuralink, for example, and there the philosophy is to stick many electrodes into the brain and use single neuron activity as the information. But this would require really an even more invasive approach. And I believe that the brain interchange system from CorTec has the very important advantage that it is really recording from the surface of the brain. This is a little bit less accurate in terms of spatial resolution, but it has the strong capability of recording oscillations from the brain, analyzes in real time, and uses information in distributed networks for stimulation. So I believe that this is a leading technology for the next 5 to 10 years and maybe even longer to come.